Hello again. Tonight we're going to talk about the benefits of looking longer. This doesn't have anything to do with height, as in, taller or longer. Um, this has more to do with observing and how often and the duration of observing. But it'll be a short presentation. I often talk about being consumed by things that I'll start doing some deep research on, and it takes me down a rabbit hole. This week I encountered a 3 hour long video that I just had to watch. I haven't watched all of it yet. I've got about 40 minutes left. Um, I was so infatuated, it just kept showing me new and interesting things. But it wasn't so much that, it was how they observed it in order to detect it and discover it. So literally, I started watching this without realizing it was 3 hours long, enjoying it. And then I came up for a bathroom break. I looked at the clock and went, I've been watching this thing for 2 hours. And then I saw that it was 3 hours long and went, I've got other things I got to do today. It's consuming too much of my supposedly valuable time. But anyway, the source of the video was Anton Petrov, and he has a channel on YouTube. I like to watch his stuff. It comes out sometimes every day, sometimes typically a couple of times a week. But it's on astronomy, astrophysics, particle physics. Very fascinating stuff. So if you're into those sorts of things, I highly recommend watching his YouTube channel. I'm not going to play any of his videos during this presentation. Part of the reason for watching his stuff is his enthusiasm and his wonder, and I can't portray that as well as he does. So I'll give you a link to his channel at the end, and I'll give you a link to the video that I watched that had me so enthralled. So go watch his channel and watch some of the videos. I should say watch some videos, not was some videos. Thank you, spell checking, spell correction. And if you've watched some of his stuff and you get hooked on it, become a wonderful person. So that's an inside joke with his channel.
Yeah.
So I watched a video that there's a link to at the end, the 3 hour long video. I typically don't watch the 3 hour long or even the 2 hour long videos of any site because you get bored. But his stuff's fascinating. So his compilation video was a hodgepodge of various things about neutron stars, quark stars, black holes, and all stuff that fascinates me. But that's not the reason I was so intent at watching all of it. It was because of how they were discovering certain things by only through long-term observations or observations across multiple spectra or across multiple observing realms. So within electromagnetic, they were looking like they would look at something in gamma and go, hey guys, look at it in X-ray or look at it in optical. So it was bridging across different wavelengths of the electromagnetic spectrum. I always find that fascinating because a lot of the emails that I get during the course of the day are notifications of these observations. And I'll see like gravity wave, which is the next bullet item, gravity wave from LIGO. And they'll say, okay, we just saw a gravity wave detection. Anybody seeing anything else in the electromagnetic spectrum? Because gravity waves aren't electromagnetic. They're gravitational. So you'll see things like, haven't seen it yet, haven't seen it yet. Oh, look, we just saw it. Because fine dust particles and such and magnetic fields tend to disperse or slow down the electromagnetic spectrum, whereas it doesn't for gravity waves or neutrinos. So I watched neutrinos as well, but he didn't get into neutrinos in this video. Some of the things that they were finding were only discovered because they were looking for a longer period of time. So, if you've ever looked through a telescope, you look in the eyepiece, you go, okay, I've seen that. They're good. You don't get fascinated and keep your eye up to the eyepiece for multiple hours because it would just get boring because not much is going on. Even if you're watching the transit of a moon of Jupiter, you look at it every so often. You don't watch it continuously. And what they found out was, some of these things that are transients can only be observed or detected, discovered if you watch long enough. And what they found out was if they watched in the X-ray spectrum, they can look at places near neutron stars, and they find other types of stars that are doing the same kind of thing at very much longer durations. So pulsars are these spinning stars that put out energy, and the Earth will see a pulse fractions of a second. And they found a pulsar that was spinning so slow that the pulse only came to the Earth every 58 minutes. So then it came into question, like, how slow can a pulsar rotate and still be called a pulsar? But it's interesting to look at this thing in radio, and you'll actually see like background radio noise, and then bing, you'll see the pulsar go up. And then they'll jump the time on the video, and you'll see background radio noise, and then bing. So the pulse from the pulsar was only a fraction of a second in duration, but the time between pulses, meaning how slow the neutron star is rotating, was 58 minutes. This is just, that sort of goes against all of the thought of what a pulsar is and how fast it has to spin and such. So, there's that. They were looking at the X-ray emissions and the gamma emissions of various supernova remnants. And when you look at a supernova remnant, you see all the gas and the patterns of different colors and such, and it all looks very fascinating. But what you don't realize is all those wave fronts of gases and particles are moving at, many kilometers per second. And by taking long duration images over years, you can actually see the growth of the supernova remnant as it's moving out. So sometimes you have to look at the same stuff for years and then patch it all together as a time-lapse video. And then when you play back, 10 seconds worth, you can actually see the harmonics of the shock wave moving out. Fascinating. And they also looked at fast radio bursts. We don't quite know what these are yet, but originally they were one of a kind, never to repeat. And now we're finding FRBs that actually don't repeat like pulsars, but they do recur. And so now it's a matter of, well, are they happening all the time, but they're being obscured by, they go behind the star and you don't see them. And then when they come back out, it's another pulse. So trying to figure out recurring fast radio bursts. They looked at black holes as to what's the minimum size of a black hole for it to still be exhibiting black hole characteristics. And what's the maximum size of a pulsar? Because, the idea is when a star ends its life, it can descend down to become a white dwarf, or it can become a neutron star. And if it's rotating, spitting out radiation, then it's a pulsar. And if it goes further up in scale, it's a black hole. Well, where are the boundary conditions? And what they're finding out is the boundary conditions are a lot softer. What's the minimum of this and the maximum of that than they used to think of. And this one was also fascinating. Pulsars that switch wavelengths and periods on a recurring basis. So you can be looking at a pulsar that's spitting out radiation in the radio band, and it does that, for very fast periods, very short duration each. And then all of a sudden, it kind of switches things up, and now it's spitting out no more radio, it's spitting out X-rays. And it'll spit out like a bloom of X-rays, and then it'll go back to spitting out radio again. And they haven't figured out why they change and why they change to those specific wavelengths. We thought this was a single star system or a two-star system. And all of a sudden we find by keep watching the particular group of stars, there's another star and it's a pulsar, but we didn't see it before. And then it disappears, and later on we'll see it again. So in space, things are 3D and they're always moving. So as the saying goes, you can observe the world in a single moment, but if you look longer, you can see more of stuff. And or in this case, this single YouTube video has a compilation of a lot of different stuff that either was below or above a boundary, or was not believed to be there and is now there. Behaviors that change. So it's a video worth watching. But as the saying goes, often the most fascinating stuff It's only apparent by looking for a really, really long time using specialized instruments. And if you remember, 2 years ago, there was a Nobel Prize given for a 21-year-long observation of the supermassive black hole at the center of the Milky Way, and they were just recording the movement of stars around the black hole. And if you get enough stars that you're plotting their orbits, you can see in the spot where there's no light, that's where the black hole is. But sometimes you have to look for a really long time. And there's Anton's YouTube channel. He started out doing math stuff. So his YouTube channel's hyperlink name is What Da Math? But now he does all sorts of other stuff. And the compilation video that I watched, there's a direct link to that. So had anyone else seen this 3-hour-long compendium video from Anton?
No, I haven't watched it yet.
Okay. But you are a watcher, right? You like Anton stuff.
Yeah.
Okay.
Yeah, he often has really fascinating videos.
See,
and he puts out, like you said, he puts out a lot of material.
Yes, he does. I often wonder what the production group is behind him, whether it's just him, because he grabs a lot of stuff and integrates it and does, overlaps in the background and lots of editing.
Yeah.
He does it several times a week. I'm hard pressed to do it once a week.
I have not watched him. I'm intrigued.
Something that interests you that is just a few minutes long, and become a wonderful person. He thinks the people stuff.
I get it. That's an inside joke. But
you can go to his merchandise store and you can buy a T-shirt that says "wonderful person" on it.
My question is does he keep things basic, or are they more on your level of? See, I'm afraid to watch it in the sense of that maybe he's going to be too above my pay grade.
I think it varies.
I think
some are more in depth and some are pretty basic.
I think Diane's got it right. I think Diane's got it. Pick a topic that interests you. Pick a duration of a video that's just a few minutes long so you can get hooked on the feeling, so to speak. And then, watch what you want to watch. You don't have to watch all of it. But I will say that, if he says pulsar, he might give you a little shorthand lingo of what a pulsar is. But when he says quark star, he doesn't go into detail about what a quark is. So he does have some prior knowledge requirement.
So just watching you has helped me out to watch him, right?
Well, I understand that I have an audience that is, wide in their knowledge. A lot of people know a lot more things about other things than I know about other things. So everybody contributes. And so I need to not just be a communicator, but I need to explain it for, the audience so that everyone can come along for the ride. And if I don't, take me to task and say, excuse me, you mentioned this. What is this? And then I look at it as, yeah, you're right. I forgot to explain what I was talking about, and therefore I'll stop what I'm talking about and explain it. And then when we go on, that will be kept in the video recording if it's something that I look at and I didn't explain that. So, yeah.
Thank you.
Okay. And like I said, it was going to be a short one tonight. I was looking to do a presentation on a different topic and a last minute thing that I needed when I ordered it on Amazon. It's not going to arrive until tomorrow. So I couldn't actually, do the scientific calculations and evaluation of what I was working on until at least tomorrow at the earliest, which would mean we just wouldn't have a presentation tonight. And that's not good. So when I saw Anton's video, I had to do something. And I've also got to resurrect one of my numerous Raspberry Pis that has a low noise amplifier on it to be able to amplify a very low voltage so I can measure it digitally by the computer. Okay. Anything else before I stop recording? Okay.